Well, good morning to one and all. My name is Dinaresh. Here is the 8th topic for the subject Power System Operation Control is the discussion regarding to the block diagram representation of the model excitation system. Let me dive into the topic about the model excitation system. Here, at first, let me know what actually the definition of the model excitation system is meant to be. Here, the system which is used for the providing the necessary field current to the rotor winding of the synchronous machine. Such type of system is called an excitation system. In other words, an excitation system which is defined as the system which is used for the production of the flux by passing current in the field winding. Here, the main requirements of an excitation system is reliability under all conditions of the service, the simplicity of control, ease of maintenance, stability, and the fast transient response are actually these few features of the excitation system. Here, the amount of excitation which is required to depend on the load current or else the load power factor and speed of the machine, which depends upon it. Here, the more excitation which is needed in the system, when the load current is large, then the speed is less, and the power factor of the system which becomes the lagging thing among among the load current and load power. Here, the excitation system is the single unit in which each alternator has its own exciter in the form of generator. Here, the centralized excitation system, which has two or more exciter and feeds the bus bar. The centralized system, which is very cheap, but the fault in the system adversely affects the alternators in the power plant. Let me know what actually the types of excitation system in the present contemporary world. Here, the system, which is mainly classified into three types, and those are DC excitation system, AC excitation system, and the static excitation system. And among these, the second excitation system, that is AC excitation system, we can see much more two classifications in this excitation system, and those are to be stated as the rotor excitation system and the brushless excitation system. Let me discuss about what actually the DC excitation system is meant to be. Here, the DC excitation system, which has the two exciters, where the main exciter and the pilot exciter, which is present in the exciter, output is adjusted by an automatic voltage regulator, which is abbreviated as AVR, for controlling the output terminal voltage of the alternator. And the current transformer input, which is to the AVR, ensures the limiting of the alternator current during a fault. When the field breaker is open, the field discharge resistor is connected across the field winding so as to dissipate the stored energy in the field winding, which is highly inductive. Here, in this present slide, we can see what actually and how the block diagram of the DC excitation system is made, how it would be. Here on the left side of the figure, we can see the alternator which is present, and it is connected to the PT box and the CT box in the series, whereas the main body consists of the field breaker, alternator field, main exciter field, field discharge resistor, and a box which is a supply for the excitation system, and it is stated to be the automatic voltage regulator, and a pilot exciter is present across the AVR, and the pilot exciter field, one more pilot exciter field is present on the right side of the main system. And for the subsystem, we can see the field rheostat is present. That's how the DC excitation system is being designed. And else, let me discuss what actually the AC excitation system is meant to be. Here, we well know about that the AC excitation system, which consists of an alternator and the thyristor rectifier bridge directly connected to the main alternator shaft. Here, the main exciter may either be self-excited or separately excited. The AC excitation system may be broadly classified into two categories, which are explained below in details. Here, Here is the figure regarding to the rotating thyristor excitation system. When we compare to the DC excitation system, it is a broader one and spread vastly to the main body when it is compared to the DC excitation system. When we think about the PT box and CT box, which is connected parallelly towards the main alternator, and furtherly it move on to the alternator field rectifier, and it was being connected to the following power supply and rectifier control boxes, and furtherly to the CD box. That's how the design of that rotating thyristor excitation system is being happen. And the main box of the AC exciter is being connected to the battery. Furtherly, in between these two, we can see the power supply, summer amplifier, manual voltage adjustment, operators, voltage adjustment, exciter voltage reference, summing amplifier, rectifier, control, exciter field rectifier were being present. Here, when we think about the summer amplifier main, here these would be impact upon the main alternator, which makes the rotation of the portion of the system. That's how the CT is being effect upon the functioning part of the rotating portion of the system. When we compare this with the DC excitation system, the field breaker between these two had a larger impact upon the power supply. That's how the rectifier control, which makes a quite difference between these two excitation systems. And the ninth slide is also an excitation system. It is stated to be as the brushless excitation system. Here, when we compare with these excitation with the rotating thyristor excitation system, it was quite different, but it would be somewhat matching with that of the sixth slide component DC excitation system. Here, whereas the shunt the shunt device is directly connected to the thyristor bridge, and furtherly it also connected on and the and the shunt end of another end is connected to the exciter field, where these three were being connected to the CT and PT boxes acrossly, whereas the main alternator field and the main exciter also been connected quietly parallel to the alternator, and that's how the regulator impact upon the thyristor bridge base adjustment and the regulator on and off. Here, this brushless excitation system makes impact upon the regulator, which to be controlled upon the thyristor bridge, which makes the output a better thing. Let me understand static excitation system. Here, in this system, the supply is taken from the alternator itself through a three-phase star or delta connected step-down transformer. That primary transformer is connected to the alternator bus, and the secondary supplies power to the rectifier and also feed power to grid control circuit and other electrical equipments. Here in this slide, we are seeing that the block diagram regarding the auto voltage regulator, where the external power source is being connected on the right end of the figure, whereas when we think about the left end of the figure, here the input material voltage RMS voltage is being sending into the PID controller, and further it move on to the PWM conversion, which furtherly move on to the AC exciter, generator, and the transformer. At last, in this figure, in this block diagram of the auto voltage regulator, we can see that the configuration in the figures 1 and 2, the block diagram of the general excitation system can be expressed as in figure number 3, where V into RMS and V by RMS represent the difference and the measured MS voltage respectively. VT is terminal voltage of the generator. V resistor is the residual voltage. V into R and V by R are the reference actual output voltage of the regulator. Here V and C is the DC link voltage. T is the duty ratio of the regulator, and KT is the gain of the transformer. KE and KG are the gains. TE and the TE were considered to be as the time constants for the AC excited generator, and KD, KP, KI, which are these are the PID gains for the controller, which make impact upon the rheostat, and that's how the red dashed block represents the auto voltage regulator, and the values functions of which can be altered by the software. That's what the representation of model excitation system is being shown. Thank you.